Start recording. Alright, welcome back everybody. This is going to be video 2, and we are going to work on tidy numbers. This is Google Code Jam 2017 qualifying round. Problem B. That's a lot of explanation for what this is. Tidy numbers. So I'll throw the link right now into Twitch, so in case anyone's watching along, they can jump in if they want. There is the code there. My chat does not appear to be showing up for me, but maybe it's showing up for you. I can't see chat. That's a little awkward. Did I say anything? Yeah, not showing up. It says I am not online, but I do believe I am online. I have 2 viewers, so whatever. Okay, not important. Let's get back to tidy numbers. You can read as well as I can, so I'm not going to read this to you. Non-decreasing order. Okay, so monotonically increasing or non-decreasing. They are called tidy. Numbers that denote this property are not tidy. She just finished counting all positive integers in ascending order from 1 to n. What was the last tidy number she counted? All positive integers in ascending order from 1 to n. What was the last tidy number she counted? Okay, so here's what we got. A number is tidy if read from left to right, it is non-decreasing. Meaning if there is a number or a digit in this number that is smaller than any digit to its left, the number is not tidy. So she is going to give us a number n, and we're going to say, okay, what is the largest tidy number between 1 and n? So that's not super duper hard. We're definitely going to be able to do this in linear case, so let's just go ahead and start writing some code for this, okay? So we're going to go ahead and make a new project, Java project. We're going to call this one tidy numbers, and everything looks great. Okay, we need to make a new source folder, which is going to be test. Okay, alright. So let's just do a class, and this is going to be tidy number checker. Okay, and to start, this is going to have one static method. Oh gosh, static method. It's going to be public static boolean is tidy, and it's going to take in. What are the bounds? Can this be a long? A large data set n is going to be less than 10 to the 18th, which is absurdly large, but I do think that is that going to fit in a long 18 digits. Here we go. Long max value. How big are you? Yes, I did mean that, clearly. Long max value. Max value. 2 to the 63 minus 1. Alright. So is this 2 raised to 63 greater than 10 to the 18th? And the answer is, I don't know yet. It's Wolfram. Wolfram alpha. Quickly. 2 raised to 63 minus 10 raised to the 18th. Okay, still overwhelmingly positive. So I do believe that this could be a lovely long. That appears to be the case. And I guess we'll run into problems if it's not, right? Yeah, overwhelmingly positive. Right, so here we go. So it's going to take in a long candidate. Now, what's interesting is that we're probably going to turn this into a string anyways, but that'll make my life easier. So I'm going to hurry and write some test cases for this, because that's how we do around here. We start by writing tests. This is the tidy number checker test, and it's going to be a test. Okay, tidy number checker, probably not like the best name for it, but for now, we don't know that. So we're going to assert true, and is, we're just going to go tidy number checker. Is tidy. Okay, what's a tidy number? 1. We'll start with 2. Why not? No. Okay. We've got some terrible things going on. It's like, I want to always import JUnit 3 for some reason, as opposed to JUnit 4. So, okay. Tidy number is tidy. 2 is returning, no, it's an error right now. So let's pull that out. Okay, so in order for it to be tidy, we need tidy checker. we're probably going to iterate from right to left, so we're coming in from the right side. And if any number on the left of us is larger than the right one, we're going to call that trouble. So, yeah, okay, we are going to collect numbers starting from the right and go left. Okay, you'll see how this works out really quick. So we're going to say string number equal to long dot toString, right? Okay. Okay, so now we have a string that represents this number. So we've got it in. Do I want to do it this way, or do I want to just like divide it by 10 every time? Okay, we're just gonna divide it by 10 really quick. Okay, so we got candidate, right? And I want a list of long. Actually, we're just make these integers, right? I can make these freaking short so long. It's going to be between 0 and 9. But list of integer and digits is equal to make digits of candidate. Okay. And import all that. Okay, so we've got a method, and it's actually going to be public and static as well. Public, static. It's only public, so I can test it. It could be private, but I want to test it in my unit test. So make digits, and it returns a list of integer. So I'll make digits. And how long it's passed in. Okay. Okay, so list of integer digits. Linked list. Could be an array list. Integer. And what size is this integer? It's going to be candidate divided by. So I need the number of digits in this. A lot of work. Let's just try and get that. Long dot toString candidate dot length. Yeah, that's pain. So here we are. That's the number of digits we're going to have. Okay, so what I want to do is get the digit that we're looking at. Now I could do this mathematically, or I could do this string-tacularly. And I probably just want to do it easiest, right? Clearly, cutting down a long into its respective digits is not like the heaviest computation we're going to do here, so let's just do that in an easy fashion. Okay, so string, here we go. String, we're naming it string, yes I know, we're bad people. ToString and candidate. I could even call it candidate string, or number string, we'll call candidate string. Great. And we no longer need this, so we can be candidate string with string.length. Okay. And then for C in candidate string, the to car array. Okay, so going through each character in it. It's not a car, it's a character. Thank you, Java. Now I need to map from C to integer. And there's probably some method that already does this, but I can just hurry and write one. So we'll just say digits.add car to int of C, right? So we're going to implement car to int. And I'm tempted to use a switch statement here, but I hate switch statements so much, so I'm just not going to. So if C is equal to 0, right, return 0. Else if C is, yeah, I'm doing this. I'm doing this, guys. Return 1. Now, there's probably a better way to do this, but I'm just not doing it. You know, I could use ASCII magic here. Be like, hey, if C equals 83 minus, you know, whatever the offset is in ASCII, but I don't want to do that. Alright, now at this point, we're just going to copy paste. Right. Is there any more of this you mean? Okay, so we got all the way to 4. So here we got 5. Here we got 6. If they ever told you in school that copying and pasting makes you a bad programmer, they were lying to you. It's a sign of a great programmer. The more often you can copy and paste, the better you're doing. It's a true story. Don't let anyone tell you otherwise. And then, actually, let's just do an else here. Else, return 9. Alright. Lovely. Just format all that the same. Okay, so we've got 0, we got 1, we got 2, we got 3, we got 4, we got 5, we got 6, we got 7, we got 8, we got 9. I think that's it. But we'll test it. Over here, we're going to return digits. Okay, so we're just adding. Great. Let's close others. We need to go to our test really quick. Let's try to test public void test 2 digits. So we're going to tidy number trigger dot make digits, and our candidate is going to be 1, 2, 3. So we're just going to say that. Should I return an array? I could return an array of digits. For now, we're going to write a list. List of integer digits is equal to that. Okay. Then I am going to assert. Assert equals. Here we go. Arrays as list. Right? And I'm going to have 1, 2, 3. Yeah, sorry about that. Digits. Let's try that. So test 2 digits, so it's worked there. 1, 2, and 3 worked. Okay, let's try a much larger one. 904, 9, that right? So we're gonna have 904, 76192. And yep, let's just not do that. Great. Oh, not passing. 9, did that work? Was not a copy paste error. Oh, righto. I need commas here. Okay, test 2 digits is working. Now let's just test every single digit, make sure we're fine. So we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Hell. And that has to be. Okay, that's working. So we are sufficiently, we are taking a long and making it into its individual digits. So that much is done. So let's go back to the is tidy. So we have a list of integer, which are the digits, and we know that those digits are right. We've split that up. Now we want to right now reverse it. Reverse it. So we're going to say digits reverse. Arrays reverse. What's the best way to reverse something in Java? We're going to hurry and. Java reverse a list. There's got to be an easy way to do this. Guava has it, which is great, but I don't. Oh, collections.reverse. Collections.reverse work? Oh, there we go. Collections.reverse list. That'll work. Okay, apparently collections.reverse works. So collections.reverse digits. Right? Does that do it in place? Yeah, that's void, so we're just going to reverse it. Okay. So now we have a backwards version that just allows us to iterate through it from front to back. So for n equals 0, I is less than digits not length size plus plus. Okay. What we need is we need a set integer. Okay. Actually, what we need is this. We need an int smallest integer is equal to integer max. Oh, yeah. Okay. Is equal to digits get 0. Okay, that's the smallest integer right now. And we'll say if digits get I is less than smallest integer is greater than smallest integer, we're going to return false. Otherwise, we're going to return true. Okay, so let's talk about what's going on right here. So we broke this long into its individual digits, so 0 through 9 digits, right? Then we reverse it. Now, in order for a number to be tidy, it has to be non-decreasing. So a number like 1, 2, 3 is in fact tidy. So we broke that down to a 1 and a 2 and a 3, reversed it, so we have a 3 and a 2 and a 1. So we say our current smallest integer is a 3. So we go through and we say that if the next integer is bigger than our current smallest, we are going to return false.
else if you do 1. Okay, now what we need is we need to update this. So the smallest integer right now is 3. Okay, let me just say else smallest integer is equal to digits.get I. Okay, since we're using digits.get I, let's be honest, current digit is equal to digits.get I. That'll work. So we say current digit, let me say is equal to current digit. That'll work. Okay, now is any of this garbage? Yeah, I would like to break this up, but for now, I think that's probably good. So let's go back to our tidy number checker test and see if this passes. And in fact, 2 shows that it is tidy. So we test 1 digit. Great. Test big number. Big tidy number. Alright, so let's see what it is. 679 is sufficient. That one looks good. Okay. Now let's test it a little bit first. Oh, here we go. 1, 1, 1, 1, 1, 2, 2, 3, 3, 3, 3, 3, 4, 4. Is that too big? Yeah, it's too big. Too many digits. Is that doing it? Yeah, less than 18 digits. Great. Okay. So let's test a not tidy number, shall we? Test not tidy number. So 21 is not tidy, right? Because it is going the wrong direction. And we'll test a big not tidy one, and we'll say 1, 2, 3, 3, 4, 4, 1. Right? Not tidy. The last one. Okay. Neither of those are tidy. Let's put the not tidy part in the middle of this thing. Let's do 1, 2, 1 right there, right? Okay. Great. Why don't we start with 2? Actually, let's start with 3. So go 3, 4, 2 out. Right? Okay. Oh, wait, we're gonna find. Oh, these are supposed to be falses. Assert false. Sorry, I've been failing this whole time and not knowing it. These need to be falses. Great. So tidy number check, we're working good on everything. Okay. So let's go ahead and pull in some of the tests that Google is giving us. Okay, and then we'll work on the input. So 4. Oh, okay. So we know if a number is tidy or not, but that's not even the question. The question they're asking is this. Given a big number n, what is the largest number that is tidy? Okay. Yes, quite. I see where they're going with this. So this will be fine in the small case, but the current plan was to iterate over the numbers and just decrement until we find one that is in fact tidy. That does not appear like it is going to work, alas. Okay, so let's just write some code that works, and then we'll work on optimizing it. So given some number, n, what is the largest tidy number that is less than n, right? Okay. So I'm going to need a new class here, which is going to be the new class. Largest tidy number finder. And it's got a public long find largest tidy number. Tidy number less than. Less, and then it's going to be a long candidate. Right? Okay, so given some candidate C, some long L, what's the one that's larger than it? So, here we go. This is terrible. Oh, tidy number checker is tidy candidate. While not that, candidate minus minus, and then we're just going to return candidate. Alright, so this is clearly never going to work in the large case, but it should be fine in the small case. So let's write a test for this really quick. There's an test case in the test directory. Okay, and we'll just use the tests that they gave us really quick. So 132 should come up with 129. Okay. Assert equals we're expecting 129 of the action, which is the largest tidy number finder dot, oh gosh, I should probably rename that so it's not quite so hard. Import that. Largest tidy number finder. Do you not have a public static method? Public static, of course you do. Okay, let's go back. Find largest tidy number less than, what was it, 134? 132? Okay. JUnit 3, what are you doing here? Get out of here. Okay. And that's passing. Now a good human right now would put this into separate methods, separate tests, right? But I just ain't doing that. So 1,000 gets 999. 1,000 gets 999. That's working just fine. And then 7 gets 7. Let's try that. Okay. Now my gut tells me that there's no way this works for the large case, but pre-optimization is the root of all evil, so let's just go ahead and make this fly. And that's supposed to be this number. Wait, is that even tidy? That doesn't look tidy to me. Oh, maybe it's backwards. Oh, that is backwards. Okay, so this is the input number, right? Yeah, okay, that's the input. That makes sense. And then that result is going to be this. Okay, so there is no way that this is going to complete. Alright, this is way too much iteration. Yeah, and see, like, we're just hanging here. So clearly, we need to do something to improve this. So the largest tidy number finder. Well, it is not tidy. Just keep decrementing it. So here's the question of the day. How do we know that it is not tidy? Well, at some point, we see a digit to the right that is less than a digit way to the left. Now, if we see a digit to the right that is smaller than a digit to its left, we need to decrement some stuff. And there's probably some decent rules about how to decrement it. So we don't necessarily need to just go down by a 1, because we can, basically, if we know in what position our not tidy digit is showing up, we can jump pretty far down to the next one, right? So what if we did this? What if the tidy number checker, okay, we can still have the isTidy method, but what if instead of returning a Boolean, this returned like the index of the non-tidy character? Perhaps the index of the largest non, or maybe the smallest non-tidy? Largest? Who knows? I need some paper to actually sketch this out really quick. So let me grab a piece of paper really quick. Okay, so for a number to be tidy, so give me an example of a non-tidy number really quick. Let's take a look at, 132 is probably that example. 132. We'll probably need like a 4-digit to actually make this make sense. But we look at 132 and we say, okay, this 2 in the last position is non-tidy. So what do we need to do? Well, we need to decrement. We need to go down. To the point where the digit to the left of our 2, basically in the tens column right now, goes down 1. And so that means subtracting 3. And then we can hurry and check and be like, oh yeah, we're in business. So basically, whatever index is non-tidy, so whatever column is non-tidy, we need to go down enough to decrement the column to its left. That's fair. Yeah, that sounds reasonable enough to me. That's a good enough way to start. Now, in the scenario where there are multiple columns that are non-tidy, well, you know what, let's start with that. So find me the column in which you are not tidy, okay? So I need, in the tidy number checker method, that's going to return the index of the not tidy 1. So we're going to call this public static int get non-tidy index. Okay? So we already know that it is not generally tidy if we're calling this method. So let's not actually reverse these digits, okay? So we're going to go from left to right this time, because that'll make my life far easier. Will that make my life easier, though? Hold on a minute. No. Here's the kicker. With it reversed, right? So if we've reversed them, and we know that the second element in the list reversed is garbage, then we know, like, oh, that's the tens column, right? And if it's the third one, we're like, oh, that's the hundreds column. Okay, so, yeah, we'll just return that. So what we're going to do right now is we're going to return I in this case. And then else we're going to return -1. Okay, so let's just do some testing really quick on this tidy number checker. Let's call test index non-tidy index, right? So this guy right here, so in the case of 21, that's not tidy, but I want this to be serve equals tidy number checker get non-tidy index with 21L. I want that to be 1. I do believe that is the case. Now that's going to return 0. And that's probably okay. Actually, let's just go with that, because that's going to be the power. Yeah, that'll be fine. Okay, so if we just run that. Expected 0, but was 1. Wow. Okay, so 2. Okay. Oh, okay. That's definitely not the way I wanted it to go. I do want to not reverse this. So let's not reverse this. So we just gotta reverse this. Our largest integer. Okay, so not reversed. If current digit is less than the largest integer, return that. Else, the largest integer is equal to the current digit. That actually might fly. So let's see if that works. Test not tidy, expected 0, but was 1. So it's not the first one, but it is that one. Now here's the trouble, right? So what if I just did this? I just did 2, 2, 1, 4. Right? What does that return? That returns 2. We want it 0, 1, 2. That's in the tens column. So garbage can, I do think that I did want to do the reverse thing. So what I want this to return, not this one, but this one. I want this to say 1. And it was 2, which is annoying. So if I debug this, sorry guys, this is getting out of hand. Okay. So we have our digits reversed. Digits now 3, 1, 2, 2. Right? So the smallest int is now 3. The current digit is there. If the current digit is greater than the smallest integer, okay, that's fine. So the smallest integer. Now the current digit is 1. So if the current digit is greater than that, okay, let's simply just be less than that. I think I had switched that. Yeah, okay. Well, that's right. Yeah. Okay, so you're fine right there, and that is 1. Okay. Okay, so getting the non-tidy index here. So the non-tidy index of this guy, so it's not, let's go from this end. Oh, that should be 0 actually. 0 is where that guy gets non-tidy. And this guy, getting non-tidy index here, equals 3, 4, 2. That should be, I'm going to make that 2 really quick. I'm just going to go to 3, 2, 4, 4. Let's try that. Okay, so expected 0, but was 3 over here. Okay. So you are currently the only non-party, right? So we go 1, 1, 2, 2, 3, 3, 4, 4, 1. Okay, I need a less than or equal. Less than or equal to. That's right. Oh, okay, it's right here. There's a good chance that's not going to solve my problem. Expected 1, but was 0. 2, 2, 1, 3. How did you turn into 0 here? Tidy number checker. Here we go. Okay. So our reverse digits are right here. 3, 1, 2, 2. Okay, so the current digit. Oh, clearly that's not what I want. I clearly don't want that. So you're failing right here. Expected 0, but was 3. So 0, 1, 2, 3. So we're not. Okay, let's dive into that guy. See where I'm messing up. Okay, now at this point I should just like stop and think about this instead of like flailing wildly at these tests, but I'm just gonna flail wildly at these tests. So I got my digits. Okay, I'm reversing my digits. So my digits now say that. 1, 4, 4, 3, 3. Okay. Oh, okay, okay. The smallest integer here. Okay, so it is reversed, and my failure is at 0. So the current digit is 1. That's great. And the current digit is less than the smallest integer. Okay, so that's fine. Okay. And now we're going to get the current digit, which is 4. So if the current digit is less than the smallest integer, which it's not. Okay, so because I reversed it, ugh, that's such a pain. So I need to detect where the first one is bad. So the next one Hold on a minute. Okay, here's the digits. I get 1. It's fine. Now I in this case is 1. I think that might be right. It's the type number checker test. It's not working. That is correct. That's correct. And that's correct. So I'm going to call that good. I believe that's correct. Now, one thing I want to do is make this is tidy check. We want to return get non-tidy index candidate is greater than -1. Sorry, is equal to -1. So we're reusing all of this code. So we should be able to just see if the index is -1, then good. Otherwise, we're okay, and that is working. So that shows our code is good. Okay, I got 3 more minutes. Okay, so now that we know where the tidy number, where the index is wrong, right? The largest tidy number finder. Try to do this. Okay, so we're going to say this. Int index, why not, is equal to tidy number checker. Get non-tidy index of candidate. Okay? And certainly if index is -1, return candidate. Now this is going to go into a loop. Otherwise, okay, so if our bad guy, if our index is 0, meaning that our 1s is the problem, we need to subtract that plus 1. Oh, this is such a pain. I want to get that digit. Get digit at index. I have index. And our method here. And so I need to make digits. Return make digits. Candidate. Get index.
we got that method. So we need to pass in the candidate right now. Okay. So we have int coefficient, whatever we call it. Okay, so that is the number that we are untidy. So we need to say candidate is equal to candidate minus coefficient times 10 raised to the power math.pow of 10 index. Cannot convert from double to 1. And it has to 1. Okie dokie. Let's try that. Alright, I'm working this tiny number trigger test. Ignoring that guy. Are you working? Probably not. Oh, that's not flying.
Hey, Miles.
Alright. Let's dig into this
So,
one.
have you ever seen a Windows program installed command line over
I know.
in PowerShell?
So get, so this can right here is 132. So get
I have,
tiny
actually, I
index
think.
is
I
0.
didn't even do
Okay.
that.
What do you
Coefficient
Someone just installed
is
Chrome
2,
in
which,
PowerShell.
that's correct. So if
Oh.
we do this,
The Chrome library went back to something stupid.
130. Oh, it's coefficient plus 1.
I don't know how we did it.
I just know, I know that there's what I thought you were referring to is there's an application where
So
you
candidate's right here,
you
132.
it's like app
Coefficient
Git PowerShell.
is 2. Candidate's now
it's
129
like
and is
the open
tiny,
source
so
thing,
we're
yeah,
returning
you
it.
can install Git in PowerShell, but
Yeah, that's good.
Okay.
They said it's like a security thing.
Making
They don't
progress.
want any duties
Almost there.
for some security reason.
Okay, so we're going to dig into this really
Windows
quick.
servers that
So
only use
candidate right now is
PowerShell.
1000. Index. Get the non-tidy index.
And somehow he got Chronicle
Oh,
installed.
that's
in there.
fascinating. Yeah, so clearly, the first non-tidy index is, ugh, that's such a pain.
Never seen it before.
So yeah, the second
Why-
index is
I really
non-tidy.
this
like-
one's supported. They can
But
they
we
did
don't
that.
need to
Yeah.
remove all of that. We could in there.
Yeah,
Just
do a new
one.
install.
Okay.
So switch to-
Sales is or just
Well,
So how do we know?
Brandon and Jalen. Yeah.
So I do
I mean
suppose
that's
that we
totally
could take the substring.
non-standard protocol.
Yeah, we don't really support that.
Yeah, I mean
So take the substring
Maybe
from the
map it out
non-tidy
and
index
look at the
and
settings and
on,
stuff.
right?
Yeah, so there's somehow like
And then find out what it's going to
Brandon
take
and Nick were looking
to
at the
subtract
installer, watching
that.
the UI, and this guy somehow
Yeah, so let's
typed
do that
in
actually really quick.
PowerShell and made the installer go through all the steps. He
Okay,
got
so
Chronicle
yeah, a
up
little overtime when
on
Ray
the
finishes.
browser on
Oh,
his computer, and then they could look at stuff.
okay. And I'm going to write this here even though it belongs somewhere else. So I'm going to say call
Recording library
substring.
that has to know.
Okay, this is going to be brutal. So here we
For
go.
some reason that's
I'm going to say hello.toString of candidate. So here we are. Dot substring. Yep, this is string.
Chronicle got us
And it's
running.
going to begin.
you just
So
use
it
it to it,
needs
just
to
with the right jar. and then use-
begin
There's just
at,
one
we'll just
jar.
say, oh gosh, it's the hard part. String, candidate string. Go on, dot toString, candidate.
Definitely know you can do that in Windows.
And
Yeah, I didn't
substring,
Install programs
candidate
in
string.
Yeah. Like when I
And
run
it's
it
like
PowerShell.
It's like a
Give
GUI
me a
with
link.
next buttons and stuff.
That's really
Minus.
great. Yeah.
Index.
Yeah.
Um,
So the index is 0.
yeah, that might be a good idea. You know, notice that there's a system ID required on the import tool, which I didn't program for.
Oh yeah, that's
So it gets getting it
Nope,
trying
no
to get
problems.
that parameter. It doesn't get it.
Okay, yeah, there it is. So if it's at 0, we're in
the
trouble.
is supposed to set
Candidate.link minus.
Oh, it's fine. I'll look at it.
Nope.
Okay. That's fine then, but I still don't know what it says
That
that.
was something we should be able to set in the UI,
Really?
so you can choose which recording library to send it to.
Okay.
Okay, so substring on this
Alright,
one is
let's
2,
do that.
and that is
I guess it's
totally
280
correct.
280 and there's no requirement.
Okay.
You can send it to the person.
So candidate, new plan, is going to be equal to candidate minus substring plus 1. I think that's enough
All
line.
of my. Where launch is saved?
There we go. Alright, so that's working. So let's check out this guy and see how we do. Oh, that goes blazing fast. Okay, so quick review of what we did. Okay, and I know this is kind of ugly code, I didn't explain it well, but what we do is we know what the non-tidy index is. So the first integer that causes us to be non-tidy. And then we take the substring of that long. So we say, okay, everything from the non-tidy part over, we're going to grab that, and we're going to subtract it from the original candidate. And then we're going to subtract one more to roll it over to 999s. And that appears to be doing the trick. So I'm going to go ahead and see if I can run this really fast. I'm going to pull in my driver from the other test, the pancake tests. And that just has the file input and output for us. So it's a little bit ugly, but let's just fix some stuff. According to it, the first input number is going to be the number of test cases, and they're going to give us a number, and we're supposed to say case 1 and what the number is. So easy peasy, Japanese. So number of test cases. So we're just going to say int long none is going to be equal to s dot next long. Okay, and then we're just going to say output case number that plus the result is going to be just tell you number finder dot find longer than. Import all that and call that. Okay, that looks like that's going to work just fine. So I just need to pull in.txt and out.txt, and we should be in business. Let's try really quickly solve the small for tiny numbers. Let's download that. We're going to save as really quick. Desktop code gem. Go into code gem. Yep, that one. Where are you at, code gem? Come on, code gem. I'm actually gonna put you in the whatever. Oh, ugh. Code gem. Save as that. Yeah, I'm not confident this is actually faster. So if I run that, that looks just fine. And then I need to choose file. It's gonna be in desktop. It's going to be in code gem. I'm going to pull sort of my fast stuff because I'm tired of looking for it. Where are you at, code gem?
Sure we don't need a document mesh? File?
Yeah, code gem. You're officially.
All the other ones
Let's just submit that.
You might
And
call that.
let's try large. Let's
Well, I'm
download
on
that.
backup right now, so.
Save it really quick.
Currently, we're
Into
supposed to have the settings.
desktop code gem.
What setting?
We're supposed to have
in.txt.
the settings.
Yep.
Like, how is this usually configured?
I'm gonna run that. Oh, bother.
It's you only need those two lines.
Let's run
and
that.
you can figure it
Okay.
out as in
And
content
that
settings.
made it into my file. Let's submit
Okay.
that. And that's correct.
So,
Excellent. All right, so I officially worked on tidy numbers and got it done for large and small for a total of 20 points. That was great gravy. All right, I will get these uploaded to YouTube with some helpful links. Thank you for watching, and I will catch you all on the flip side. Thanks, guys. Bye. Doo-doo-doo.